Okay, so we are. I jump around a little bit, just like I said before, just because that numerical method, it's simple but just monotonous. Um, but we're talking about separable equations here, which is it's a real easy version of a differential equation that um, we can solve, right? And so we're working on just solving diff EQs today. So I gave you this original, this is number 3 in section 7.3. But I solve for y prime, and then that's my differential equation. So I want to put that into a slope field right away, right? So I've got GeoGebra open. I just search for slope fields, and I pick the very first one. Anyone that you can put your you want to make sure you can put your diff EQ in, right? So I have x over y divided by quantity x squared plus 1. I want to talk about the slope field. So first of all, look when x is 1 and y is 1, right? Right here, right? When x is 1 and y is 1, yes? So I'm actually putting in those values, 1 and 1, into x and y. And so what do I get? I get 1/2, right? Can you see that? If I put x in as 1 and y in as 1, upstairs I get 1 times 1, downstairs I get 1 squared plus 1. So it's 1/2. So that slope right there is a slope of 1/2. And that's what I'm doing to create, so at every integer, I call them crosshairs or vampire points. Everywhere there's a crosshair, right, I'm going to put in those integer values of x and y. So for example, it looks kind of like I have a slope of -1 here. It might be off a little bit, but what is that? X is -4 and y is 4, right? So if x is -4 and y is 4, that's a 16, -16, so definitely negative, over 17. It's close to 1. It's not, yeah. So that's how the slope field is created. It's that simple, right? So that's what I'm going to do first, and this is going to set me up for an initial condition. So meaning if I knew that when x was 0, y was 1, right, then I could set up the initial condition and then see if I'm correct anyway. So, but let's go back to our piece here. Here's what we're solving, right? So I rewrite y prime as delta y over delta x, and then try and get all my y terms on one side, including delta y, or dy, and all my x terms on the other side, including dx. And then once I get there, I'm integrating, right? So L of the absolute value y, and on this other one I have a u sub, right? So I get 1/2 of the ln of x squared plus 1. How are we doing there? Yes, okay. I'm definitely going to raise both sides base e, right? But if I can, I'd kind of like to get that 1/2 out of there, and I can. Ln of the absolute value of y equals the ln of the square root, right? Excuse me. And now I'm going to raise both sides base e. My e's and my c's are starting to look the same, but so I get absolute value of y equals, before I take care of this e and ln canceling, I want to write it as e to the c times e to the ln, right? just so I can see I'm going to get some constant out front of my square root. And so then I can finally say, all right, this is y equals plus or minus some number times the square root of x squared plus 1. So there's the solution to my Diffie-Q. Of course, I should be able to check it like we did yesterday. We should be able to put it into the Diffie-Q and make sure it works. That's one way. The other way is to give it an initial condition, or we can actually plot this with a slider of k, right? And it'll show us the family of functions. Of course, k is 0, right? If I go here, if I have my 0, 0, of course k is 0, right? I can see that solution for sure. So let's see what we get here. So I like going to Desmos here. I don't know why I feel like I have a mistake, but y equals k square roots of x squared. Oh, no, I don't. I know what I'm thinking. And I got my slider k, and you can already see there's my k is one solution, right? Exactly. Yeah, so our Diffie-Q was first derivative, okay? So integrating, we return to a family of functions, right, that will satisfy that particular thing. And if we know initial condition, right, if I know the point 1, 1 is on the curve, I can find the exact value of k in that case, right? So if y of 1 is 1, that's my initial condition, right? I know I could plug in y is 1 and x is 1. I can figure out k. And obviously, k is going to be a positive 1 over square root of 2, right? Or rad 2 over 2. So if I put that in, what is rad 2 over 2? 2.24? Yeah, I'm just lazy. No, I'm wrong here. Sorry. I can just type it in, right? Okay. So there, right? So now you see where it hit my initial solution. So so the part of solving is easy. It's chapter 5 again, right? Really. And then verifying, very simple, right? With Desmos, with GeoGebra, that type of thing. What's confusing about it to anyone? Say again? So more than x and y? Oh, okay. Yeah. So, but I would think the constant might be a little bit like when does it turn into k, that type of thing, and you just you can let it ride as long as you want. You can have that e to c there for as long as you want, and make that your whatever you want. It's just we're trying to see something that's not changing, that has several little pieces to it. And let's simplify it if we can, right? Let's do another. So textbook. Oh, I don't have it open yet. Sorry. So what's Evil Robert going to do on a chapter 7 quiz after our first exam or on the second exam. He's going to put in a Diffie-Q that's going to make you do a trig sub or a by parts or etc. Right? Oh my God! Look at this stupid thing. Yes, me. I want to get in my computer. I mean, what kind of security are they worried about here? I can't get in my computer without a phone call. Stupid.
I was doing Authenticator app for some
Yeah,
other thing,
yeah.
and it like broke, and so now I can't get it.
Oh no, that sucks.
So like, and it's like it was like for some paycheck, it's like a bank statement.
Oh no. Now I can't find my current course here.
I don't like that. Why? All of the completed courses.
I know. It's so stupid. And it's just such a horrible piece of software too. I don't know if any the computer science people agree with me. I hate it.
You just like search for the course.
Yeah, I guess but I don't know which course it is.
Or
Oh, okay, thanks.
I just like to control that.
All right, one more. There it is. Yeah, please, will one of you get your degree and then get rid of Blackboard forever? And I think we pay millions of dollars to use it. I'm sure. I'm sure it's a crazy amount. All right, we did number 3. The thing that I'm worried about when you go to Diffie-Qs, right? The three of you, when you go into Diffie-Qs, it's all applications. It's all applications. And inside of the application, you've got to do the calculus, okay? So just don't have a panic attack. Read the textbook ahead of time. Get the Shaw's outline for Diffie-Qs, okay? It's every possible problem ever solved, right? That's what Shaw's outline is for any course. For the computer science linear, get the linear and the advanced linear. The linear will have all the problems. The advanced linear will have all the proofs. Okay, so, but you're ready for the next class. If you're doing all this calculus, you're ready. And any teacher, you can handle any teacher if you can do this stuff. All right, let's do another one here. Let's do, let's just do 11. Nice and easy, right? 11. So, of course, you can do any of these up to, I mean, everything is from what I can see. Up to 31 for sure. So let's do 11. I've got my Diffie-Q is x over y, and an initial condition of 0 and negative 3. So 7.3, number 11. I've got y prime equals x over y. We can do some slope fields. So at 0, 0, I'm in trouble, right? Right? At 0, 0, I'm in trouble. Yes, you with me? And in fact, anytime my height is 0, my y is 0, I've got perpendiculars, right? So I'm kind of doing my slope field by hand here, right? If I go up to 1, y is 1, and x is variable, right? I can see the slope will just come from x. So when x is 1 and y is 1, I got a slope of 1. when x is 2 and y is 1, I have a slope of 2. So you can kind of see I'm going to be getting some kind of, I'm going to get some kind of a net like that, right? It's so silly to do it by hand, though. So we're just going into our piece here. So x divided by y, and enter. Yeah. Yes, because you can't, because 0 is a problem for y.
Like at 0, I understand.
Yeah.
Like when I get near 0, like
Yeah. Yeah, there's a little weird cross thing happening here, right?
I think mine is like faulty programming or something.
Yeah, it could have an issue. Yeah. So they gave us an initial condition of 0, -3, right? Yeah. Yeah, I'm using Ken Shorts. Yes, by dragging. So what I do is I drag that initial condition. All right, let's solve it. So what are we doing? We're taking our diffie-q. We're going to look at the slope field. We want to look at a possible initial condition solution, right? So we want to find the general solution. Then we want to find the initial condition solution, and then check it with Desmos, right? That's what we're going to do on all of these. So what do I get? I get dy dx equals xy, x over y. It's kind of a nice one. And you should kind of see, you know what you're going to get out of the other side, out of the right side. You're going to get a quadratic again, right? But what's going to happen on the left side is also a quadratic, which is why when we look at the slope field, where am I? When I look at that slope field, you can see I get quadratics in y left and right. You see it? And I get quadratics in x up and down, right? So I get an x equals y squared over here. I get a y equals x squared over here, right?
I see this problem as x over y. That's
No, x over y. Yeah. Unless I'm losing my mind. No, that's a comma. Yeah, that's a comma for the initial. It does look an awful lot like a prime, but it's not. Yeah. All right, so what do we get? We get y squared over 2 equals x squared over 2 plus c, right? Yes, you with me here? So remember, I want to solve for y. I get y squared equals x squared plus 2c. And do you see that now is a pretty good time to take 2c and just call it something else? I would just call it c again, or they use k so it's not confused with the original c, but who cares, right? So I definitely get y squared equals x squared plus k, and then of course my square root, right? Now that to me is a little funny in that k value, right? The k value will never affect the plus or minus piece, right? So a little confused by it, but let's take a look anyway. I'm trying not to jump the gun a little bit, right? I want to go to Desmos. I want to look at that general solution. And I'm going to just keep it, I just want to look at the positive pieces first, right? So I have the square root of x squared plus k, right? And I'm going to put the slider k in there. And without changing, right, this guy, but you can still see, you see I'm getting the y version now of the quadratic, of the parabola, right? But it really only wants to give me 1/2 of it, right? And the problem is, of course, that I don't have the negative out front to get the bottom half of it. But I don't want both curves, right? I only want the quadratic and y on one side or the other. And so what's that going to give me? It's going to get me that from that initial solution. What was my initial solution? Forgot. Yes. Thank you. Yeah, y of 0 is -3. So x is 0, right? So y of 0 is -3. So when I'm plugging in x is 0, I get a y of -3. Okay, look at what that's telling me. Look at what it's forcing me to do, right? You can see what is it forcing me to do? It's forcing me to put a negative out front of my square root. So that's how I know which one I want, right? So I get -3 equals negative square root of k. So k is obviously 9. So now I have my initial solution of y equals negative square roots of x squared plus 9, right? Yes, everybody, this is easy, right? Yeah, it's easy. So I told you 7 was easy. Chapter 7, very easy. Chapter 8 is a beast. But you can do it. So I want to go to my I want to go to my slope field again. I'm doing all of this on a quiz or anything, right? And 0, -3, right? There it is. And I want to go to Desmos and double check it, right? So I've got it, gonna change my k to a 9, and I'm going to change my positive to the negative. There it is. And I'm going to put in my point. I want to double check that I've got that original knowledge on there, that I got that initial value on that curve. Pretty damn easy, huh? All right, let's do a tough one. Don't let me go too fast. So again, I've got a general solution and then initial value solution, right? So a couple here look kind of interesting. Is everything okay? Yeah. Go ahead. No worries. This one's one of my favorites. I usually put it on the test, but it's hard to make them nice. But this one is pretty nice. So I got y prime equals x plus y. So far you should have noticed that I'm multiplying or dividing all my pieces together. Now all of a sudden I have something that I'm adding. So y prime equals x plus y. Let's put that right into our slope field. And this one's got some pretty funky solutions. No, I guess not. Thought there was a place where it went kind of crazy, but It looks to be pretty normal. Behaving decent. Well, and the book gives you a hint here. And I'm going to make a u sub. I'm going to let u equal x plus y. So now I have y prime equals u. Right? But the trick is going to be to differentiate this piece with respect to x. So we're doing d dx of u equals d dx of x plus y. So I get du dx, right, equals what? 1 plus y prime. Right? So so when we do this u sub trick, which is, a bunch of problems here in a row here in the textbook. Where is it? So 19, 20, 21, 22, etc. There's a bunch of them like that. So it's the same trick every time. Make a u sub, take the derivative of that piece, so that now you can see, right? What do I have here? I have du dx equals 1 plus u, and that is now separable, right? So I get what? 1 over 1 plus u du equals dx, right? You with me? Nice. So that's just an ln on the left side, right? You agree with that? You're okay if I'm jumping to things like that? So on the left-hand side, I have the ln of the absolute value of 1 plus u. Don't forget what u is, though. It's x plus y, right? So 1 plus x plus y equals x plus c. Right? That okay? Absolutely. So I got the... Right, I know it's an ln. It's just a shift, right, of 1 over u, yeah? So raising both sides to e, right, I get absolute value of 1 plus x plus y equals e to the x plus c, which of course I can rewrite as ec times e to the x, right? E to the c times e to the x. And then to kill that absolute value, I need the plus minus, right? And at that point, I'm going k. I'm solving for y. So I get negative 1 minus x plus or minus k e to the x. So there's my general solution. Doesn't seem to be any restriction on k, right? K seems to be fine, so I can just let it run wild in Desmos.
You can take that plus or minus to just be part.
That's true. That's true. I don't even need the plus minus because I know k can be anywhere, right? That's true. I don't even need the plus minus because k will take on the plus or minus when I put in my initial condition. Yeah. So slope field. Desmos. Right? Y equals negative 1 minus x plus my slider k e to the x. Yep. And so if I had tangents on this line, and anytime I froze it, they left the mark of where they were, move it again, leave the mark, move it again, leave the mark on all the tangent, little tangent lines on it, you would see the slope field, right? Cool. And let's see if we have an initial condition in our textbook. This was number 21. No initial condition, but I can always put that in, right? I can always take my general solution. So like in my slope field, I can pick a solution, let's say the ballerina 0.22, right? And so if I say I have y of 2 equals 2, right? I know 2 should equal negative 1 minus 2 plus k e to the 2. Oh shoot, this one sucks, huh? It's not that bad. What is it? 4. Don't tell me. 5, right? 5 equals k e to the 2. Oh, so k is 5 over e squared. Yuck. Did I do that right? Yes. So now I can go to my Desmos and change my k value, right? 5 divided by e squared. And I'm just looking at, let me kill this. Oh, I don't have a k anymore. That's fine. So there's my solution. And look, right? So practice anything in 7.3 up to number 31. Do the process, right? Get the slope field, initial condition, general solution, initial solution, check on Desmos. There could be a couple that are pretty tricky, but let's see what happens. Nice. Let's do a nice easy quiz and then go have lunch.